Just when scientists thought they had seen it all, the James Webb Telescope comes along to reveal the existence of peculiar, cotton candy-like planets. While these fluffy exoplanets might sound like a whimsical cosmic phenomenon at first, they actually present a genuine mystery. Their surprisingly low density relative to their size challenges our current understanding of planetary formation. In theory, the process seems straightforward. According to established models, gas giants, such as Jupiter, form once they accumulate a solid core of at least 10 Earth masses during the early stages of their star system's development. It is believed that a planet can retain a thick gas envelope even when exposed to strong stellar winds, at least, that's the theory. However, real discoveries in space reveal exoplanets that challenge our current models of planetary formation. One such anomaly was first recorded in 2017. Situated approximately 212 light-years away, this exoplanet, named WSP-107b, completes an orbit around its host star in under 6 days. Initial observations indicated that it was a gas giant comparable in size to Jupiter. However, follow-up studies in the following years uncovered an intriguing and puzzling detail. Ensures that it can hold on to a thick gas envelope even in the face of strong stellar winds. Well, at least that's the theory. But if we take a look at the real discovery in space, we see that there are also some exoplanets out there that pose serious problems for our current models of planet development. The first of these outliers was added to the star charts back in 2017. Located around 212 light-years away from us and christened with the scientific name WSP-107b, this alien world orbits its host star in less than 6 days. The first observational data already suggested that we are dealing with a gas planet about the size of Jupiter, but the follow-up studies over the next few years were to finally bring a rather confusing circumstance to light. The experts specifically analyzed what is known as radial velocity. Even at an extremely close range, and despite the inability to answer these profound questions with absolute certainty, one thing was clear to astronomers: the enigmatic candy floss planet is a true anomaly, an outlier that defies the established mass-radius relationship of planets. And that is undeniably correct. However, if scientists at the time had already been aware of Kepler-51's companions, they would have realized that such anomalies are far more common in the vast universe than previously believed. The James Webb Telescope's remarkable discovery reveals that, in terms of mass, the Sun and Kepler-51 are quite comparable. However, their planetary systems differ significantly. Situated in the Cygnus constellation, about 2,600 light-years away, this young star hosts not just one or two, but 3 candy floss planets. In a way, the mystery of how their gas envelopes form and persist is threefold in this case. To bring more clarity to the mysteries of the cosmos, a research team led by Jessica Libby Roberts from Pennsylvania State University closely examined the planets of Kepler-51 for the first time using the James Webb Telescope. However, when they aimed the telescope at the star just before the expected transit, they were met with an unexpected surprise: the planet's shadow appeared much earlier than anticipated. Due to a significant miscalculation in timing, the researchers ended up witnessing not the beginning, but only the final moments of the planetary transit. In numerical terms, this meant that the exoplanet Kepler-51d crossed in front of its star a full 2 hours ahead of schedule. Fortunately, the team had begun their observations several hours earlier to capture baseline planetary starlight, allowing them to detect the anomaly in the first place. A minor transit deviation of a few minutes is understandable, but a discrepancy of 2 hours is a completely different matter. What could have caused the planet's early arrival? That was the pressing question, and co-first author Kento Masuda from the University of Osaka openly admitted his astonishment. The unexpected early transit of Kepler-51d left him and his colleagues puzzled. No matter how they adjusted their 3-planet models, none could account for such a significant shift in transit times. Additionally, the possibility of an error by the James Webb Space Telescope was ruled out, as the early transit had also been confirmed by the Hubble Space Telescope and multiple ground-based observatories. Ultimately, the mystery was solved by expanding the model to include a fourth, previously unaccounted-for planet. This celestial body appears to orbit Kepler-51 at a greater distance and along a more inclined path. Consequently, from Earth's perspective, it does not cross directly in front of its host star, but its gravitational influence significantly affects the movement of the other planets. The researchers concluded that the best explanation for their findings is the presence of a gas planet with a mass comparable to its 3 counterparts. This means the planetary system around Kepler-51 has gained not only an additional member, likely orbiting its star in a wide, circular path with a period of 264 days, but also another puzzling lightweight, now named Kepler-51e. While its presence slightly increases previous mass estimates, the planets in this system remain too light to fit within our conventional models of planet formation. Adding to the mystery, Kepler-51 hosts an unusual, cotton candy quartet, despite most such fluffy planets typically appearing alone in their home systems. However, scientists cannot rule out the possibility that even more exoplanets are lurking beyond. Researchers now aim to study Kepler-51's orbit in greater detail using high-resolution spectra from the James Webb Space Telescope, hoping to uncover more about these strangely inflated worlds. This extraordinary planetary family continues to captivate scientists. Beyond the cotton candy-like discoveries, exoplanet research has yielded other unexpected findings in recent years. While the similarity among planets in the Kepler-51 system only adds to its intrigue, astronomers have identified another system that stands out for its remarkable diversity. This intriguing system orbits the star WSP-132, located approximately 400 light-years away. It consists of a super-Earth, a hot Jupiter, and, further out, a massive ice giant. The term super-Earth refers solely to a rocky planet's large mass, without implying anything about its composition or habitability. In contrast, a hot Jupiter